I know the value of. So Isabella, what are the names of the two sides here that I know the value of? Okay, so my adjacent and my hypotenuse. Those are the two sides I know the value of. So, what is the only trig ratio that involves adjacent and hypotenuse? Oh, hold on. Sorry, 1 second. Let's change this a little bit, guys, because it's too easy. We've already done this. So let's make, instead of that, let's make the 3.3 this side. My mistake. 3.3 is going to be that side. So we're going to change it up. Instead of adjacent over hypotenuse, we're going to use opposite over hypotenuse to solve this. We're going to pretend this is the side 3.3. Opposite over hypotenuse. So what is the trig ratio that involves opposite and hypotenuse? Victoria, what do you think? Yes. So you're the first person that hasn't said sin today. It's the sine ratio. So sine of angle A is equal to opposite over the hypotenuse. We're going to use this to solve for angle A. Angle A is my only unknown. That's what we're trying to solve for. So I'm going to fill in the rest. Sine of angle A is equal to 3.3 over 5.3. 3.3 over 5.3. So in some ways this is easier because we don't have to do any cross multiplying. However, this problem is going to have an extra step. The reason we don't have to do any cross multiplying is because I don't have a letter on the right hand side or variable. I only have numbers. So you can simply plug into your calculator 3.3 divided by 5.3 and you're going to get 0.62267. It's going to be a lot of numbers. To get the most accurate answer when you're solving for angles, always keep 4 decimal places until you get to the final answer. The final answer can have 1 decimal place, but in your process, you can keep 4 decimal places. Even in university, they'll tell you that. 4 decimal places when you're doing trigonometry to get the most accurate answer that's closest to your textbook answer. So on your calculator, you're going to get a whole bunch of decimal places. I just kept the first 4. No need to round or anything, just the first 4 decimal places that you see, okay? So does that mean that angle A is 0.62 degrees? That's less than 1 degree. That sounds like awfully small. That's not the case. There's an extra step when you're solving for angles. So I'm not interested in sine A. I'm interested in angle A. So if you have a calculator out, get it out and look at it. I always draw a rectangle around this next instruction because I want it to look like a button that you press on your calculator. This is called the sine inverse, and to get that on your calculator, you're going to punch second function sign, and then the sine button. Second function sign. And this is called, I should write this down because everyone always forgets it, the sine inverse. You can do the same thing with cosine to get the cosine inverse, tangent to get the tan inverse, but this is how we go from decimal to angle measure. So if I punch in second function sine, I get the sine inverse on my calculator, and I type in 0.6226, this number that was right here, you're going to get an answer for the angle measure. Angle A is equal to 38.5 degrees. So that's how we move from the sine ratio to the measure of angle A, okay? It's very, very important when you're doing your homework, when you're doing your test, draw a little rectangle